All right. Well, we are going to get started here. It's 8:30 on a dreary Friday morning out in Carroll County for me. Welcome to session number 5 of the Iowa Ideas Conference. I'm your moderator, Jared Strong. I'm a reporter for Iowa Capital Dispatch. This session, Next Steps for 3D Printed Homes, is within the Economic Development track. Our panelists will discuss the benefits and challenges of constructing buildings with a robot that squirts out concrete, and then I'll address your questions after I'm done grilling them. Unless your questions are better than mine, then we can just switch to them. But all our sessions have closed captioning access, and all of our sessions are being recorded. And we'd like to, before we begin, recognize our sponsor, ITC Midwest. So today, our panelists include Zach Mannheimer, founder of Alquist 3D, a company that 3D prints homes, who also happens to be dashingly handsome. We have Abby Gaffey, a community development field specialist for Iowa State University Extension. The university is doing 3D printed home research and developing training programs for community colleges. And we also have Ron Monahan, Housing Initiatives Manager for the Community Foundation of Greater Muscatine, which is commissioning a series of 3D printed homes in his area. So to start us off, I'm going to throw it to Zach, and I'm just going to ask him to give us sort of a boots on the ground overview of what his company does and why.
Sure. Good morning. Our company does exactly what Jared was saying. We use large robots to squirt out concrete and print homes. I wish it was as easy as that. But we started our work back about 3 years ago here in Iowa, specifically because we saw the housing shortages in every community around the state and really around the entire nation. Myself and my colleagues have been doing economic development work mostly in rural areas for about 15 years now around the country. We've come up with ideas and solutions for many of the problems that plague these communities, but housing eluded us for quite a while. In 2016, I went to an event that was a presentation by a futurist. I don't know how you get to be called a futurist, but that guy certainly was, much like our friend Jared Strong, definitely a futurist. And he talked about a lot of things, one of those being 3D homes. And I'd never heard of anything like that before. And somebody in the audience raised their hand and said, hey, how long until 3D homes, this type of construction is the normal construction here in America? And this is back in 2016. And he said, well, given the issue of land availability and affordability in urban areas and unions and zoning, et cetera, I'm going to guess about 10 to 15 years. And I think he's a good futurist because I think he was right. And then afterwards, I went over to him. I bought his book so he would talk to me. And I said, your point about urban areas and doing this work is, I think, accurate. But in rural areas and smaller communities where this could move faster, don't you think that this technology could take root there sooner? And he said, I never really considered that. You might be right. And that set me off on lots of investigation and research gathering, et cetera. In 2020, we received a grant from the state of Virginia to print the first home there, and that gave birth to Alquist 3D. We started doing our work there. We printed several homes in Virginia. Now we're here in Iowa, in Muscatine, working with Ron and his amazing crew to print homes there, and we're spreading around the country. We just announced a move of our company to Colorado. So at its base, the goal of 3D printing is to make the American dream come true for those who cannot afford it. And it's to drop the affordability and up the sustainability. I would say this is still a work in progress. In America, we've been printing as a country for about 5 years. We're still very new into this technology. The good news is that we've made a lot of strides, and I'm sure we'll get into that along the way. But I'm very bullish on this technology, and clearly, I am a terrific tech nerd because I'm the only one who could not figure out how to put my background on.
Well, Zach, so if for people who aren't familiar with 3D printed homes, how do you distinguish them from a stick-built home, like from the outside? How do they look different?
So the main thing here is that if you do it properly, you don't need any exterior cladding on the wall systems. So it is concrete. You can paint it or not. You can certainly put any cladding or any material over the concrete if you don't like the look, but of course that just adds to the cost. So there's a lot of different looks. The traditional look is sort of that tubular, almost toothpaste-like sausage look of line by line by line. That's layer by layer of the printing. Same thing on the interior. There's a lot of ways to change that look with different nozzles and different exterior methods. But if you don't touch it, that's typically the way that it would look.
And you guys have been doing this for a little while now. Stick-built houses have been around forever. How mature is the 3D printed home industry?
Immature. I would say that we're still at the very beginning of this process. Can we do it? Yes. Is it reaching the affordability levels that everybody wants? No. That's still an ongoing challenge. We're getting closer. But there was a lot of misinformation about this back in 2017, 2018, when I was first learning about this. And this is a lot of people's introduction to 3D printed homes. There's a lot of information out there that says, hey, you can print a house in a day and it costs $10,000. That's what got me excited many years ago. That is false. No company is even close to that process. And really in America, there's about 10, maybe a dozen companies right now doing this work with any success. There's a lot of other groups that are going to be coming online over the next couple of years. So our anticipation is that we are going to hit the affordability levels that we want here in the next, I'd say, 2 years. The goal for us is to see a 30% savings versus stick built. But there's other things to consider that are advantages to 3D. First of all, these homes are energy efficient. They cut your energy bill in half by 50% or more because the walls are thermally broken. So you've got a significant savings there. The other piece, of course, is that these are sustainable in terms of what it can do standing up to major natural disasters and storms. In many cases, these homes can withstand 175-mile-per-hour winds. They don't burn. This is the future of construction. And as long as we live in a world where natural disasters are now common, we have to change the way that we're building. We needed to do this before anyway. So this is the natural advancement of the industry. It's not like we're going to put stick built out of business. We're going to be a natural complement to that. And I also think we can merge with the modular industry as well.
Abby, tell us a little bit about how you're helping the industry with research, helping create best practices and figuring out how the best ways are to build these homes. And tell us about is it called the Franken cabin? Is that what you guys call it?
Yeah, I think Zach has probably seen the Franken cabin as well.
It's an appropriate name.
Frankenstein collection of how we're testing different things. And that's really, Iowa State University is a land grant university. We're here to provide research. And what makes a land grant different from any other university is that a lot of the research that we do has to be applied and it has to be applicable to Iowa communities that are our taxpayers that paid for all of this to happen to begin with. So one of the things that's happening within this innovation, because we're really at the innovation stage right now, is that a lot of things haven't been subject to scientific study yet, right? So a lot of the companies, for instance, that are working in this field are kind of monetizing the mix, the concrete mix that they're using. And what we're trying to do is provide more of an open source for that so that we can take a look and see what is going to work best in Iowa. So Zach is experimenting in one realm of that, and we're experimenting in another realm of that. So some of the things that we're doing, our state would like us to look and see, are there byproducts that are part of other Iowa industries that we can use to bulk up this mortar? Because it's really more mortar than concrete that we're working with. So we're doing things like smashing up wind turbine blades, because we got some of those sitting around that we can repurpose, things like that, glass beads, corn stover, any kind of things that we could throw in to kind of bulk it up. And we have teams of scientists that are material scientists who are looking at things like how well does it stand up to compression, right? Because there's a difference between concrete that's laying flat, it's a street. We know how to build streets. We've been building streets forever. We know what the thickness it needs to be, what the consistency needs to be for it to withstand the weight of semi trucks and trailers and cars and everything else going over it. But it's different when the concrete's standing up, right? And it's holding up a roof. roof or it's holding up a foundation. So we have to figure out how does concrete withstand reconfiguring like that. Looking at things like if we have to transport pre-done panels from Fort Dodge to Hamburg, Iowa, what is the transportation cost of that? Do they crack? Do they withstand moving about? We know that concrete cracks, so we need to test things under different weather conditions. So that's why we have the Franken cabin that's out behind the communications building on campus. Is one half of the cabin is all 3D printed walls, different kinds of insulation plugged in, different windows, different doors, so we can kind of test how that works. And then the other side of the cabin is traditionally built using the same windows, the same doors, so we can plug some, excuse me, some sensors into those, and we can kind of track how do they stand up. Because what we don't want to do is lure people into an industry that's not going to be profitable or sustainable for them. So we want to make sure that what message we're giving to Iowa industries, to Iowa home builders, to Iowa communities is something that we can back up with the science and give them some reassurances that if they step into this field, that they won't lose money doing it, that it's something that we can provide a product that people want, that it's a kind of home that people could be comfortable living in. So that's one of the things that we're working toward. The cabin, we're going to take the cabin concept, and in the spring, we hope to be printing our first kind of experimental house in Hamburg, Iowa. And Hamburg was flooded in the 2019 Missouri floods. So we're using some state CDBG Community Development Block Grant disaster recovery funds to kind of do an experimentation as part of a 33 unit subdivision. We will be doing one of the houses. It'll be a bungalow designed by BNIM architects, and then immediately next to it will be the exact same house as a stick-built house, both of them with sensors on it, so we can see how do they track as far as energy usage, how do they track as far as comfort, what does it cost to cool them, to heat them, what's the maintenance on them, are they comfortable to live in, are they humid, how do they react under humidity conditions? How do they react in storms? So we'll have two houses side by side that will have been experiencing the exact same climate, the exact same weather conditions, and that'll help us really document and quantify how well they stand up performance-based side by side.
Or maybe it's too early to at this point, but what have been some of the results of the testing at the Franken cabin? What have you found so far about the comparison between the 3D printed side and the stick built side?
Well, at the moment, we're still tracking those things. We had it all out over the summer. We have an exact duplicate of it that's up in Fort Dodge at Iowa Central Community College. So there's a stick-built Franken cabin, and then the Franken cabin that we can't keep our hands off of. So we're always messing with it. We're always touching it. Like Zach talked about the sausage look of things. So we keep kind of trying to smooth it over, see if we can make it look more like stucco. Kind of just playing with it to see what can we do with this. And so we have several different varieties of printers. We have a robotic arm printer, a couple of those that are down on our campus and at Ames. Then we have a giant, what's called a gantry printer that works on tracks. We have a giant one of those that would be capable of printing something maybe 2 stories tall. That's at Iowa Central Community College in Fort Dodge. So we have a variety of different kinds of printers we're playing with, different kinds of concrete mixes, different kinds of aggregate that we're throwing in to work with it. And then documenting all of that, looking at compression strength, looking at how long does it take to cure or dry before it kind of slumps over. If anyone's ever done pottery or ever seen the movie Ghost, and if you just touch it, she's doing her pottery and all of a sudden the whole thing just falls over. Concrete does that too. So we have to figure out where do those things happen at as we keep print higher and higher and higher. Where does it get where it starts getting, a little wobbly or not quite to the spec that we want it to be. Then the other thing we're looking at is there's really no building standards for any of this. So we're working with the National Building Certification Group called ASTM, looking at how do we develop standards that local communities can inspect these things too, right? So a local inspector who's working on a 3D printed house knows what it's supposed to look like, knows what the dimensions are supposed to be. Right now, we're just kind of copying the building code that we would use for concrete masonry units, CMUs, concrete blocks. We're trying to kind of mimic that as much as we can, but what special adaptations need to be done to building codes and inspection codes so that we can make these housing products safe and that we can verify that they're going to be safe as they're being constructed so that when they are for sale, somebody knows what they're getting.
One before we go to Ron, just one quick question, Abby. Is the research at Iowa State based around sort of our climate here in Iowa? Or are they creating? Is it possible to create separate climate conditions to see how it would hold up in other parts of the country? Probably difficult, huh?
We haven't cared that much about how it stands up in other parts of the country. We're more concerned with us. But one of the challenges is that Iowa has a very fluctuating climate. So when we think about our traditional construction season, we can have temperature variability that goes from it being 50 degrees in the morning to 100 degrees in the afternoon. How do we compensate for that? How do we figure out, how do we do a construction on a site that we can maybe provide tenting over a structure, that we can maybe do some climate control to keep a little bit more consistency? Because that is one of the things that we need to deal with, is that we have such a kind of volatile climate and a very short construction season. How do we adapt ourselves construction wise to how concrete reacts to various kinds of climate changes in temperature and humidity, rain, snow? I mean, all the different things that could potentially happen as we're constructing in our construction season in Iowa. So that's what we're looking at. That's what the value of the Franken cabin is, that we can set it out there and see how it reacts in different kinds of weather. We can purposely say, let's go out and see how we do if we can print in the rain. Let's go out and see if we can go out and print when it's 100 degrees. What does it do then? So having something like that is lets us go and experiment in a way that no one's going to be impacted. If the Franken cabin falls over tomorrow, no big loss, right? We're just out the materials, but we can experiment with these things and see how do things react in real life.
All right, Ron, let's hear about the Community Foundation of Greater Muscatine, this housing initiative you guys have, and then why you have selected 3D printed homes as the path forward for your program.
So I think to dovetail where Zach started, Community Foundation has been involved in a number of initiatives here, basically starting with family stabilization. We believed housing is a core piece of that. So that was our next initiative, was to move into the housing side. And as you do that, we put together a team that explored a number of different alternative building methods. We looked at structurally engineered panels, stick-built homes. We looked at ICF construction and 3D construction. And that probably took a period of a couple of years, I believe, to look through all of that. We were intrigued by 3D construction. And I think, as everybody on the panel has mentioned, at that time, there were actually very few companies doing the work. So we began to look around, at least in our area, through that research, went through an RFP process. I think we had 3 responses. One of them had a printer, but it never printed. One of them was a general contractor that was interested. And then there was Alquist, who had actually built in Virginia. So through that process, we landed and partnered with Alquist to build here. We've committed to build 10 3D printed homes by the end of 2024 in Muscatine County. We've started 4 of those, by the way, are projects directly from the Community Foundation that we will fund, we will sell. And then reuse those funds, importantly, reuse those funds to build more homes in the county. So We bought 4 lots in probably, I think it's fair to say, a middle class subdivision in the city, fully ready to be built upon, and started last spring. And throughout the process, what we found is it's important to build a team around you, because I'm not a construction engineer. I'm not a concrete guy. I'm just a project manager trying to figure out what 3D printing is. Fortunately, we have lots of partners in the state that can help us. We spent a lot of time with the team at Iowa State University, understanding what they're researching and what it means, and spent a lot of time with Zach and his team, looking through the process. And I think Zach would agree, it's been an interesting experience in Muscatine. Everything Abby described, you're doing it in a research environment. We're doing it live, building a home. And I think Zach would agree, the weather in Iowa is not always like the weather in Virginia. And every day can be very different. And as Abby described, we had those mornings where it was cool, and by the end of the day, it was hot, and it did change things. So, matter of fact, I think one of those days, Zach, we had record heat indexes in the state of Iowa.
Yes.
So I think we're on our 3rd material on our builds. And actually, this material I think is very promising. In the first set of walls, we did have some issues with them. And I think, as others have said, it's concrete. There's nothing new about building with concrete. There's everything new about building concrete the way you're building in 3D printing. So it's a different process. The material is not your basic ready mix. So you have to understand all of that. And I think the key component, though, is, and Abby mentioned it, it's concrete. It's going to crack. It's a matter of making it crack where you want to, no different than a street or a sidewalk. So I think we've explored different, through Allquist, different means and methods to get there. We're starting our second of 4 houses, and we believe that we've made some design changes with the Allquist team that put some turnbacks in places that make sense. And the early results, again, are very good. But again, our starting point was the fact that our community is no different than any other community in Iowa or most of the communities across the country. We desperately need housing. We're fortunate enough to have major employers, but we also have, I think the number is about 11,000 people that drive into our county every day to work. We just simply need places for them to live. And again, Zach mentioned it. There are lots of theories behind 3D printing. One of them is quicker to market. We're not exactly sure we're there yet. We fully believe we can get there, but we're not there yet. And it's the affordability factor that's the other piece of this. If we can drive the price down, and some of that is, you have to get to the point with critical mass, I think. You look at what they're doing in Texas and other places where they're building 100 in the same site. Mobilization is a big piece of the expense. You just simply need to be able to move from pad to pad to pad and build. So we're building here. Our first 4 builds are about 1,420 square feet, 3 bedrooms, 2 baths, oversized 2-car garage, 0 entry. And again, we're in a middle class subdivision. We were fortunate enough, by the way, the city was fortunate enough to receive a grant from the state, a $1.8 million grant to build 6 of these on infill lots in our downtown neighborhoods. And I think 3D printing becomes more interesting on an infill lot. Some of these are not standard lots. And some of them, in a different situation, if we tore a house down, we may not get a variance to build back. So I think on some of these sites, 3D printing may be a more viable option to rebuild. And some of the price points are low enough that 3D printing may be the only alternative on some of those sites. So again, in our case, we took the leap and got into 3D printing. We're doing live research. And I think Zach would agree, there's a fair amount of experimenting happening every day, from equipment to material. But I will say this, and I say this to some groups. The robotic arm is really cool. We're using a robotic arm, and we've seen rooms just literally go silent once that thing starts to move. I still believe the rock stars are the folks running those things, and the guys that understand the material, that can make the code work, and that understand when something may not be going right and it's time to slow down, speed up, or stop. Because the human element is still incredibly important in the process.
Ron, do you have any idea yet how much how much you're going to sell those houses for?
The 4 that we're building in Arbor Commons are probably going to be 300-ish, give or take 300,000. Obviously, when we get to the infill lots, that will be a different number. But that would probably be the going rate for a 1,400 square foot home in our area.
And how does that compare? Because you said it's in a residential subdivision, right? So these houses are going to be in with traditional stick-built houses. Do you know what the values of those houses are that have already been constructed there?
The early construction in that area actually was above what we thought it might be. So the early houses constructed are probably in the 400,000, 450 range. And I think that price is a little higher than even the city anticipated for that area. However, recently the entire subdivision was sold to a builder developer who is in the area right now building other stick-built homes that'll be in the $300,000 range. So I think the neighborhood will settle into that range after those initial builds. So we should be right in the same neighborhood, price-wise. Now it has been interesting from a community perspective to the adaptation to a 3D printed home. And it's unfair to the product at this point because we don't have a roof. So right now it's a rough looking set of walls. And until you make it look like a house, it looks like everything you don't want it to look like. Looks like a prison or everything but a house. We just need to get a roof on one.
Well, Ron, you sort of alluded to some of the challenges of finding the right materials to build with. Zach, can you talk about going the struggles that you guys had to sort of find that right material to use in Muscatine, and any other challenges, primary challenges that the industry has right now? And if you could too, we have a question from the audience that fits in with this. Yep. That's that you might have seen. Yeah, do you guys use rebar? Do you use just like the fiber mixture to strengthen the concrete? What do you guys do?
So a lot of information here, and I want to come back to when I'm done a comment that Ron made, which I think is very wise, is the human element piece of this. That is, and this is something that we're working on now, and we rely on our friends over at Iowa State as well on a training program, but I'll come back to that. So to answer the audience's question, do we use rebar and all thread and things like that? The answer is yes. Do we think that we can get away from it? The answer is also yes. So right now we are putting rebar. So when you print the wall sections, you're printing two sides, the inside and the outside of the wall. We do a 3-inch bead on either side in width, and then there's a 6-inch gap. You can make it any size you want. That's just where we've landed with our structural engineers. Inside that gap is where you put your rebar. We use all thread that goes into the footings and will eventually connect into the bond beam, which is how you attach the roof. And in that gap as well is where we insulate. So right now you can use any insulation you like. We're using spray foam insulation typically. We run our electrical conduit inside that gap as well. In addition to the rebar reinforcement, we have steel ladder systems that lay down on top of the concrete roughly every 12 inches. We install that manually and the printer prints directly over that. When we get to window systems or door systems, we use a steel lintel that goes along the top. And again, the printer prints along the top of it. I would call this method primitive. in this industry. We want to get away from that. We believe that the concrete and the structural integrity of the home will be strong enough to be supported, especially for a single family home, or excuse me, a single story home. Will be eventually get away from that steel systems that we install. We're not there today. So it requires more experimentation. That's another thing that we would love to see from Abby and her team over at Iowa State. With their research is fantastic. So we'll get away from that eventually. The concrete that we want to use, I'll stress that want to use, is coming in, should be around 7,000 PSI when we're done with it. And this is after a 28-day cure time. We've tested it above 14 days. We're already surpassing 5,000, which is right where we want to be. The concrete that we were using beforehand, the other two materials that we used did not even hit that 5,000 that we needed it to. And that was a concern. Part of that, I think, is probably weather. Part of it is the material itself. Part of it could be human error. So in general, the way to look at this is that to get to the cost savings that are necessary to really scale this industry, there's 4 pieces of the puzzle. Ron's touched on one, which is scale, where we can be printing, 100, or not even 100. We can be printing 10, 20, 30 at a time. That's going to drop some cost because you save on mobilization. Another one is speed and time. Now, this is typically, if we're using the right material and we have the right labor, we can print pretty quickly, and we can beat the time that it would take to stick build a home if all things are going correctly. We're not there yet. That's part of the reason why the material needs to perform and the humans need to perform. On the human side, there is not a program that trains people in any major way across the country on how to use this technology. So you can't go off into the street and hire anybody to join your team. It requires tons of training, which requires tons of time and money to do so. To that end, we're looking to fix that problem. We're working with the Muscatine Community College on a training program that hopefully gets started next year. We're also working with a community college in Colorado on a program that will be started this year. So training is going to be a big thing. And that's another element of the 3D side that I think gets overlooked. This is a significant opportunity for workforce development, to put a lot of people back into the trades, particularly people that don't want to necessarily go for a 4-year secondary degree. They want to go right into the workforce. We can create that. And I know we've had dozens of conversations. I see Abby nodding, that working with Iowa State and others, this is what we want to do. This is a big benefit to it. But then on the material side is probably the biggest place to drop the cost. So you can drop the cost by having experienced labor, so you can print faster. You can drop the cost by having the right robot. And I think we have the right robot with the robot arm. But again, it's the training and the material that need to come together. But the material itself, I can tell you that the Quickcrete material that we were using in Muscatine, also the similar material that we used in Virginia, averaging around $800 a yard. To put that in perspective, you need about anywhere from about 25 to 30 yards of this concrete to do this home. That may not beat the price of stick built because of the material cost. Part of that is shipping. And part of that is just because there isn't a lot of companies that make this material. In fact, Quickcrete made this initially for us in Virginia. They made their initial mix 2 years ago. We need to drop the cost of the material. We knew that coming into this in any project. The material we're using currently is coming in closer to $350 a yard. We also think that we can get that even lower. Now, this is going to be a proprietary material that we're working with a lab in Maryland to create this material. So far, as Ron said, it's very promising. We're far from all the way home and knowing this is going to be the solution, but we feel really good about it. To the question of, do you put fiber in it? You don't have to put fiber in your material. I would recommend it. Part of the reason why the material we're using currently is performing so well is because it does have fiber. The last 2 materials we used did not include fiber in that mix. But then, of course, we're looking at the experimentation that Iowa State and others are doing of how do you use recycled materials? How do you use fly coal ash is a big thing that we're looking at. The material we're using currently does include fly coal ash. And when the tests come back in about 30 days, we'll know, the manufacturer believes this mix is going to be carbon negative. We don't know those results yet. We're hoping it is. That is another goal of ours, is to put less carbon into the environment by using this method. So there's a lot of pieces of the puzzle to answer here. We've learned this in the fire by going out there and doing projects. We haven't had the luxury of doing a lot of R&D, which we'd like to do. We rely on our friends at Iowa State and other areas that are doing this research and sharing that with us, and we can inform them as well. This is an emerging industry. This is like Silicon Valley in 1972. There's not too many people doing this work. We all know each other. For the most part, we play nicely in the sandbox. And this is emerging. And we're looking forward to having a lot of this work be here in Iowa.
So Jared, if I could jump in just for a second here, Zach mentioned the training in MCC, Muscatine Community College. I believe it's still true that they have the only hemp research program in the state.
Yes, good point.
And they will be researching the addition of hemp fibers into the Crete mix. MCC's also just recently opened a significant improvement to their campus, a career advancement center, where they'll be teaching the trades, HVAC, carpentry, all of those things. And what I failed to mention on our builds is that we are not building 3D the interior walls. So the interior walls will be built with traditional materials, traditional methods. So even with what we're doing, we still need we still need the trades. We still need plumbers, electricians, HVAC people, roofers, carpenters to build out the inside of the house. So we may be building 3D homes, but we still have a need for traditional trades within the construction industry. And I think we all need to remember that. So it's really expanding the opportunity rather than shrinking the opportunity, because many of these homes are at price points that a lot of contractors may not want to be involved with, but the trades can still be there.
Yeah, Abby, I want to go to you to talk about the curriculum you guys are developing, but one real quick question for Zach. When you talk about the new jobs that are associated with 3D printing homes, is it like a robot operator? What are these jobs and what do you think they would pay, annually?
We're actually creating robot costumes that people will wear and be able. No, I'm joking. Yes, there's 4 particular areas for these jobs. Robot operator, the printer operator is probably the most popular one. And that's really somebody that knows how to code. A lot of this goes into the code, and then a lot of it is experience. And Ron was alluding to this earlier, but the human on the job site that knows when to extrude more, extrude less, depending on what the weather is doing, the humidity is doing, that's what you're watching for. And the performance of the material, and just knowing the experience of when there is a problem, knowing how to solve it. So that is probably one of the most important pieces. It's the pump operator. And this is another piece, is that the robots are amazing, but the pumps and mixers are still primitive. We've gone through, I think, 4 different pumps and mixers. We got a new one 2 days ago that we're constantly trying to see, because the pump can't keep up with the speed that it has to push the material through the hose to the nozzle head before the material seizes up. We've gone through many hoses. We have a saying at Alquist, which is, when in doubt, check the hose. And so it's the pump operator, and really that person is the material director, understanding the material, knowing how much needs to go out of the silo, because we're mixing all of our material on site. That's an important part. There's a lot of discussion around the idea of getting a ready mix truck to come to the site and pump the material directly out of the truck into the nozzle. We think that will be something in the future, but we have to be at scale to do that. So pump operator. Then there are the folks that need to walk along with the nozzle right now to make sure that everything is happening correctly. Now that position could eventually be eliminated with GoPros and adding water tanks to the actual robot that waters the material as it goes, if it does need water. So the 2 main roles are the printer operator and the material designer. Outside of that, then you get into the home design as well. This is when architecture and design come into play. We think this is going to grow that industry dramatically, because it's going to be so exciting to get into that. So those are the roles that are being created. We're imagining this, or not imagining, we know the program is going to be a roughly 8-week certificate course. It requires no prerequisite, so anybody can do this. And this is how I think we get young people back into the trades. And to Ron's point before, this is how we inspire others that need to do the other build out of the home, like he was saying. It's important to note we're really only replacing about 20% of the home. The rest of the home is still built the same way you build any other home.
Abby, if you want to take it away with what you guys are developing there, and just a note to the audience too, we are closing. I mean, we've got 20 minutes left, so if you have questions for these guys, please submit those. So, Abby, what's Iowa State doing to develop curriculum, and who are you working with on that?
Okay, well, we are working with Iowa Central Community College in Fort Dodge, and we're taking their existing carpentry program, adding an additional year to that program to create an associate's degree that they can get in what's called additive construction manufacturing, which is the technical term for 3D printed houses, right? We can't even agree on what we really call these things. Anyway, so the first class of students is going right now in ACM 1. They're in class right now as we speak, and what they're doing in their week 7 is this week they're learning how to create a digital twin. So they're taking a design of a house and they're doing it on a desktop printer so they can see where a mistake might be. So they're learning how to look for mistakes in the code. They're learning how to look for a mistake in a system. On a smaller scale, we'd rather find this out when we're using about $3 worth of materials than when we're using $800 per yard materials. So we need to figure out how can we catch mistakes cheaper and quicker. So that's one thing that the students are learning how to do this week. Then the next semester, they'll go into ACM 2. And here's my thought on this as a community development person and as someone working in workforce, is it would be a shame if these students that we train just go out and take a job for $40,000 a year. We want some of these students to embolden themselves to become independent contractors or to start a company doing this. So next semester, they're going to spend a lot of their time on entrepreneurship. And we're going to work with the Small Business Development Center on how they can put together a business plan, what would be the cost of starting up a company doing this, what kinds of things would they need to purchase, and then we're going to turn to the state who's been funding this and say, fund these people. Give them money to get started so that we can get some things happening out in rural Iowa where it is very difficult to get housing happening. I work primarily in housing. And so what we find is that unless you're within an hour of Des Moines, they can't stage a crew and get any number of houses done. As at the university, a lot of times we come in after a disaster has happened, whether it's a flood or tornado. One opportunity is we might have to be in a position in rural Iowa to crank out a lot of housing really fast. This is an opportunity that this is a real viable way of doing that. So the training courses that we're putting together, we hope to have a curriculum that we have tested, that we've tweaked, that will lead to good paying jobs and the possibility of people starting their own companies, that looks at the material science portion of it, that looks at how do you code things using CNC and G code is what all these things operate on, teaching these students how to do that, giving them some confidence to know where do you find house plans, how do you work a printer, how do you clean a printer, how do you maintain your investment. So looking at all these little facets and getting people interested in it. And what's nice is that this opens up the field of construction to people that would not typically be working in construction, because so much of it can be done with computers. It opens it up to females. It opens it up to people who have handicaps. In fact, the architect that we're working with on these first bungalows is in a wheelchair. So it's bringing people into the field that maybe would never have considered construction an opportunity for them. So those are some things that we want to look at, is how can we reduce the barriers to entry into construction. Another thing that we have to kind of bear in mind is that, oddly enough, considering in Iowa where we're at, the two industries that are the slowest to ever adopt innovation are construction and agriculture. So we have to get over this fear of making changes. Because the world has changed around us and we haven't necessarily kept up with it. We lost so many of our tradespeople during the 80s. When we went through the farm crisis, a lot of people who were working in trades, that was their off-farm job, and we lost all of those and we never replaced them. So that's how we ended up, in some respects, this is how we ended up in this situation where we have some of the oldest housing in the country. old housing, like Zach pointed out, that is susceptible to floods, it's susceptible to fire, it's susceptible to wind falling over in a strong wind. So we have a lot of housing that exists in the state that is subpar, that needs to be replaced and replaced in a pretty aggressive building schedule, like Muscatine is doing. So we're looking at communities where how can we use this technology to maybe be able to do a lot of housing quickly if there's a disaster? How do we use this innovation to be able to affordably build housing that's under 300,000? Because we know in rural Iowa, we have a lot of places where 300,000 is the top of their scale. How can we get this closer to 150? Or under 200? What can we do to address those issues? And so part of our research is economic as well. We want to make sure that as we're doing this, that we're tracking our costs and comparing apples to apples. So one of the things we're doing is we are this fall starting focus groups with construction trades, people who have received contracts from the state for CDBG type programs, to get a handle on what are the construction costs that you're coping with now. And then we're working with the Iowa Home Builders Association that is going to survey all of their membership so that we can start getting some really solid cost comparisons so that we know what we're comparing this to. Any other I see some questions coming in here.
Yeah, let me ask you one thing before we get to the audience question. Say, Abby, I finally get tired of getting angry emails and phone calls from people who don't like the stories that I write, and I want to make a career change. You know, how soon am I going to be able to enroll in one of these programs that you're developing?
Well, you can enroll at Iowa Central Community College right now. Our hope is that we'll try to at least make sure that we have 4 community colleges that are trained so we can cover each quadrant of the state, so we wouldn't have students that would have to travel terribly far. My thought also, because I'm an extension, is that we have to be able to develop training courses for existing people within the construction fields at a company that they work at. So we might have a company that takes this on as part of their line of business. So how do we take this information and compress it? Right now we're doing, 2 semesters. How can I get this into maybe 4 weekends or 2 weekends or some form that an existing company can take advantage of and train their existing workforce? So there's a lot of moving parts to this. There has to be, but we have to just kind of keep thinking about how can we make this viable business in Iowa.
And if I
Zach,
can
I interrupted you.
Yeah, just to jump on that, first of all, if you're looking for a job, Jared, we can talk later. But to Abby's point, to get a big thing that she mentioned that I love is the entrepreneurial aspect of this, of getting folks wanting to get into this business. And frankly, the reason why people have not gotten into the business in a major way here in America is because of the hurdle of how much it costs to get in and the time. And we're literally creating the best practices as we go. Not everybody is as crazy as I am and my colleagues to jump into this 3 or 4 years ago and really try to figure it out as we run. Now, we're close to being able to get groups in with a lot of the knowledge now. And certainly the programs that Iowa Central is creating are going to help with that. At Alquist, we're starting a franchise operation that'll be ready next year for groups that want to get into this, but don't want to spend millions of dollars and years of their life to try to figure it out. Part of the other issue is that there's nowhere you can just rent a printer to use for a period of time to see if this is even for you. So that's changing as well. We have a new partnership with a group out of Arkansas that has been leasing heavy equipment for 50 years. They're going to run our leasing program, which starts next year. So you can rent one of these printers for 2-3 months, see if it is for you before you make the investment to purchase one. And then if you want to do the franchise or if you want to go through the program like Abby has, there's going to be options for groups of people to want to get into this work. So that's exciting. And the audience question here on it's what issues occur when a wall is at half the height and the pouring process is interrupted by a malfunction? Does the process have to be continuous like slip form construction? So as you're printing, you can stop and start. Certainly you'd like not to, but you can stop, fix the problem. We've done this many times and then keep printing again. When you're finished printing for the day and you're not at full height yet, what we do is overnight, we soak burlap. We lay those over the wall systems and then cover that with poly so that the concrete can cure overnight. The next day when we come back, we spread paint on a adhesive, a bonding agent, directly onto that top layer where we stopped, and we start printing on top of it right away.
Zach, out of curiosity, how much does one of these printers cost? And if I want to like get one for a couple days, you know, what would I have to pay for that?
Well, I'm afraid of what you would do with one, Jared. So I'm not sure if you're going to be able to get one. But there's two types of printers on the market. There's the big gantry style printers, which we have used in the past. Those are terrific once they're set up. The gantry printers run for a little over $1 million. Those are the ones capable of printing a larger scale home. There's disadvantages to those printers, but that's the price point for those. The robot arm, like the one that we're using in Muscatine right now, those sell anywhere between 200 and 400,000. So they're much more affordable. They're easier to transport. There's disadvantages and advantages to everything. I wouldn't say there's a perfect printer on the market today. I'd say we're at Robot 3.0 in the marketplace right now. I think we need to get to Robot 6 or 7.0 before we really begin to perfect it.
Got an audience question here about how HVAC is done. Do you guys have, what am I'm losing, like the standard, like conduit, I don't have the right word for it. You guys use mini splits for that stuff. Duct.
The HVAC
duct work.
Is it easier or harder to, so it's easier to heat and cool. So this is how we did a study with Virginia Tech that determined that the energy usage in a 3D home is at least 50% less than a stick-built home. And this is because with that 12-inch wall system, your walls are thermally broken. So the walls don't heat and cool like traditional lumber does. So you're not having to run the HVAC nearly as much as you would in a traditional home. So that's obviously an advantage. In terms of installing it, you would install it the same way you do any other home. Now, we allow for, during the printing process, this is when we're adding vents or sockets or junction boxes. There's two ways to do it. You can do it while you're printing and cut into the wet concrete and form your box then, or you can wait till after you're done and slice into the concrete and cut it there. There's, again, advantages and disadvantages. I don't think anybody's perfected that just yet, figured out exactly the best process, but you can do either.
So along those lines, we in Muscatine on our first 4 houses have actually chosen a different method. As far as the conduit is concerned, we're not running it through the cavity in the wall. We plan to, on those interior walls that are 3D printed, to flush mount that in an industrial look. And part of that is the affordability factor. If we don't have to have an electrician on site to do that work and we can flush mount it, we can drive the cost down. And even the other piece to remember is that we're stick building the interior walls, which means you can do traditional electrical work, HVAC work on those stick built walls. So it's really the exterior walls that present a different challenge.
All right, we're coming down to it. We got 7 minutes left. What are some of the other, we've talked about all kinds of benefits of these houses, but what are some of the limitations? You know, I think, Zach, you and I talked before about basements and roofs. You know, what are the sort of the remaining challenges you guys still have to figure out?
So in Iowa, I know everybody loves their basements, and I say this speaking from my basement. But Alquist and myself, we are anti-basement. I know it's an unpopular opinion, but the reason why is normally you want basements for shelter from storms. Well, that is mitigated by being a concrete home, and it's far more cost effective to add 500 square feet or so onto your first floor than it is to dig an entire basement. That being said, can we do basements? The answer is yes. Now, prior to us using the robot arm, when we were still using the gantry system a year and a half ago, the answer was no. The gantries cannot do basements. But you can dig a basement, build it out traditionally, and you can print right on top of it. That's fine. But to print a basement, you need the robot arm to be able to do it, to either stretch down into the cavity or to place the machine down there once you've dug and print out the wall systems. We have not done that yet. So that's something that we're going to be experimenting with over the next year. But we know it's possible. And in terms of the roof, we have not printed a roof yet. We do know it's possible. And that's something where I think Abby's research is going to be crucial in terms of we would most likely prefabricate those roof systems offsite and then transport them and to install. So that's something we have not done yet. And we're going to look to the research that Iowa State and others are doing to determine if we should.
So with the issue of basements, before we started our first home, we actually pulled together realtors and other people to have exactly that conversation, because basements are crucial to not only living in some cases, but in almost every case storage, because we all have stuff and we all need places to put stuff. Our realtors are telling us that more and more homes are being built without basements, which means you need to be more creative with storage space. In our case, we've oversized the garages to give a place for bicycles, lawnmowers, and whatever else may need to go there. When we get to our infill lots, we won't be building basements there. There may not be room for even a garage. So we're needing to be more creative with just floor plans to create storage. Some call it a ski closet, things like that, where people can keep stuff. But again, our realtors are telling us that the trend is away from basements on moderately priced homes.
Yay.
I would like to just say to close on something is if people have an interest in 3D housing and want to look at an inspiration point, I would point them to a TED Talk by Jason Ballard from Icon Construction in Texas, and how he got involved in this, having worked in homeless shelters in Colorado, and what kind of inspired him to even do this. And take a look at some of the things that Icon has done. I found that extremely inspiring about what could be accomplished, how things could look and be beautiful. You look at some of the houses they've done, the designs on them. You're not limited to having walls that are completely square. Things can be round and curved and strengthened and even made more beautiful than the type of construction that we have available at a much higher cost. So if you're looking for inspiration, Jason Ballard's TED Talk is a place to look.
Yeah, along those lines, I've listened to Jason, and it is uplifting to see what they're doing and why. But I will say this, and Zach's team hasn't always liked this, I don't think, but we put a 24/7 camera on our first build. His team was on show all the time, but our sites are in a public subdivision. We get lots of drive-through, and we get lots of phone calls for people that just simply want to come and see. So if you're in that exploratory stage of wanting to or thinking about the business, our sites are always open. And Zach's team has been incredibly gracious about showing people what they do.
Yeah, the 24-hour webcam seems kind of dangerous at a construction site. Does everybody have to wear belts to make sure their pants are upright and in the right position? Anyway, you don't have to answer that.
Thank you.
Okay, 2 minutes remaining. Last question. Zach, you mentioned that cutting through red tape to get these houses built in cities can be an impediment. Talk a little bit about that, and how I think you said it's easier to do it in a rural community than in a bigger city.
It is an impediment, but it's increasingly becoming less so. The two biggest questions we get are, number one, how do you hang a picture on the wall, which is concrete anchors? That's an easy one. But the second question is always, how do you pass code? Can you get past code, et cetera? And the answer is, can you? Yes. So we've worked to get past code in Virginia, Florida, Iowa. We're almost past it in Colorado. And in all those cases, the code did not have to be changed. That's important. We've been building concrete structures around the world for hundreds of years. This is simply an advancement of that, and we get better all the time. So yes, there's red tape, but you can get past it pretty well. That should not be a concern for anyone wanting to go into the business.
So Jared, in Muscatine, when we started talking about 3D homes, we pulled the city people into meetings very early so that they knew what we were doing and had a chance to do their homework. And I would agree with Zach, that they really worked off existing building codes and adapted. Because to Abby's point, that the code just doesn't really exist for what we're doing. But we didn't find that to be an incredible burden here. And I think it was because we prepped the city and brought them along with us.
Good deal. We just rolled over 9:30. So thank you for joining us. Thank you, audience, for joining us. Thank you, panelists, for a very interesting talk. And I look forward to seeing some of these homes in the future.